In this lesson, we're going to be talking about Theorem 4-6, which is called the hypotenuse leg, or the HL theorem. Now, this is a very special theorem. We've so far have covered 4 of them. The first one, that's a shortcut to proving that 2 triangles are congruent, is side, side, side. The second one that we looked at was side, angle, side. The third and the fourth ones had everything to do with angles, which the third one was angle, side, angle, and the fourth one being angle, angle, side. Now, today's lesson is about the hypotenuse leg theorem, which is going to be our 5th one, or the HL theorem. Okay, so it's all on its own, hypotenuse leg. Now, what's so special about this particular shortcut is the fact that you need to have 3 things in place in order for this to make sense. Okay, so side, side, side means that all 3 sides in both triangles are going to be congruent. Here we have side, angle, side, which means that if you have one side congruent to the corresponding side in the second triangle, and then the angle and then another side also corresponding in the second angle and second triangle, and they're congruent, then you have 2 congruent triangles. Here you have angle, side, angle. Here is angle, angle, side. And the last one has to do with right triangles. Now, the 3 things that you need to worry about when you're dealing with HL theorem, remember this is a theorem, and the rest of them are actually postulates. So all these 4, the first 4 are postulates, and the last one is a theorem. Okay? So the first thing that you got to look for, if you're going to call 2 triangles hypotenuse leg, and then you can call them congruent, is the first thing is you have to have right triangles. Now, you'll notice in the first one and also in the second triangle, you have these symbols that indicate that both of them are right triangles. So this first part, you can check it off. They are both right triangles, so that's a good thing. Okay? The second thing you got to look for is the fact that the 2 triangles need to have both hypotenuses, yes, that's a word, hypotenuses congruent. The triangles need to have both hypotenuses congruent. Okay? And the third thing, but if you notice here, before I go on, PR is the hypotenuse for this one. Remember, the right angle faces or points to the hypotenuse. So this right angle points to this, which is PR, and that has a double tick mark. And then you look over here where the right angle is for the second triangle, and that points to this side, which is XZ, and that also has a double tick mark. So we can say that the 2 triangles, both hypotenuses are congruent, so that's a check. Okay? And the last thing you got to look for, which is number 3, is the fact that the triangles need to have one pair of legs congruent. Okay? So what exactly is a leg in a right triangle? Well, a leg is either side. It doesn't matter which one. So we can say PQ, XY should be congruent, or QR and YZ should be congruent. At least one of those 2 pairs needs to be congruent. And if you notice here, that's got a single tick mark. This has a single tick mark. So QR is congruent to YZ. And so we have one pair of legs congruent. Okay, so we can check that off. So what are the things that we're looking for? Are both of these triangles right triangles? Yes. Okay? The triangles need to have both hypotenuses congruent. So we have PR is congruent to XZ. And so both of those are checked off. Remember, you need to have at least 3 things, 3 in both triangles to be congruent and to be able to use any of these 5 shortcuts to prove that they are congruent. And so the third thing is the triangles need to have one pair of legs congruent. So if you look at QR being congruent to YZ, we have three things in both triangles corresponding to each other, so we can say, yes, these two triangles are congruent. We can box that in. Okay? So these three have to be in place so you can say HL theorem. So you say, yes, these two triangles are congruent, and if they ask you to justify your reason, you would say the HL theorem. It's that easy, okay? So you would say HL theorem. Now, I've chosen three different examples so we can look at to prove that two triangles are congruent, and we can actually use the HL theorem. So here's the first example that I've chosen, okay? Example number one. If you look at A, B, C, and we're trying to test to see if D, E, C are congruent to each other. Okay, so this is triangle number one, and this is triangle number two. And we're specifically looking for the HL theorem. So the question would probably ask, are triangles 1 and 2 congruent to each other? Then they would probably ask, if so, comma, justify your answer. Okay? So we're looking at triangle number one and triangle number two. Okay? A, B, C, and it's being compared to D, E, C. All right? So let's see if we can use the HL theorem. First of all, do we have two triangles that are right angles? Yes, we do. So we're on the road to choosing HL theorem so that these two triangles are congruent. Okay? So both triangles are right triangles. All right? So that's the first one. The second one is we need to have the hypotenuses congruent to each other. So the opposite of the 90-degree triangle or 90-degree angle is AC. Now, it does not show that they are congruent to each other, but that's a double tick mark. And this is the part that I left out so you can actually see it. The book actually indicates that AC is congruent to DC, which is a single tick mark. And these are the hypotenuses for both triangles. So AC is congruent to DC. And these are the hypotenuses, and they are congruent to each other. The last thing to call this HL theorem and both triangles to be congruent to each other, we need to have one of the legs congruent to corresponding to the other triangle. So let's look at AB. So AB is congruent to DE. Are these legs corresponding to each other? Yes. Is the hypotenuse congruent from one triangle to the other one? Yes. So all three pieces of information that you need to call these two triangles congruent to each other by using the HL theorem are there. You have to have right triangles. That's in place. You need to have both hypotenuses congruent to each other. Those are congruent to each other. And the last part is the triangles need to have one pair of legs congruent, and that's the case for both triangles here. So BA is congruent to DE, and that's the last piece. There, you need three pieces of information so you can use a shortcut. So basically what I'm showing you today is about HL theorem. Remember, there are 5 different shortcuts: side, 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 angle, 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 side, and the HL theorem. So we're going to prove that triangle 1 and 2 are congruent to each other using the HL theorem. So how would you write it as an answer? You would say it like this: yes, comma, triangle ABC is congruent to triangle DEC by the HL theorem. And that's it. This is showing your work right here. Making that list and checking them off is proving this statement right here, because we're able to say the HL theorem because we know for a fact that these are right triangles, the hypotenuses are congruent to each other, and the legs are congruent to each other. You have another angle that you can actually see, which are vertical angles, but that's not necessary for the HL theorem. Okay, the second example that I wanted to show you is on the opposite side of my paper here, but all you have to do is just watch this video and just be prepared for tomorrow's lesson. Are these two triangles congruent? Justify your answer. Well, we have this triangle over here, which is triangle number 1, and we also have this triangle over here, which is triangle number 2. Okay, first of all, you do not see for a fact that these two are right triangles. Okay, but something very interesting, ST, segment ST, is a straight angle. Okay, since it's a straight angle, the two angles that make it up add up to 180 degrees. So angle SRP already is stated that both of them are congruent to each other. And the second one is TRP. Since both of them are congruent to each other, that means it's the same angle, right? Since ST is a straight angle, if you were to add up this angle plus this angle, you're going to get 180 degrees. So let's call each angle X. And the reason why I'm going to call it X is because this amount of degrees is congruent to this amount of degrees. And so I'm just going to label this X. And this one, I'm going to label it X. Okay? If I was to add up those two angles together, I would end up getting 180 degrees. And when I add up these two variables, remember, algebra is very important in geometry. Most of the time it is one-step geometry, and the rest will probably be algebra for you. So the angle, or angle X, is going to be 90 degrees. So basically what I'm showing you is, since both of these angles are congruent to each other, and ST is a straight angle, the only two angles that can fit right there is a 90-degree angle. So do we have, in fact, two triangles that are right triangles? Yes, we do. So both triangles are right triangles. And so we have the first one in place for this. The next thing that we're going to see is the fact that we have a leg on both triangles congruent. And a lot of people will probably say, well, I don't know anything about SR and I don't know anything about TR. But what you do know is that RP is shared with both triangles. If I was going to separate these two triangles, what I would do is I would cut using a pair of scissors right here, RP, and that would actually separate both triangles. So RP is the same in both triangles. So what I'm going to say is RP is congruent to itself. And if you remember what that's called, it is the identity property. Identity property. And remember, this is a leg right here. This is a leg that I can say is congruent to itself. The last piece of information, and I really should have put it second, is the fact that we know the hypotenuses are also congruent to each other. Since this is a 90-degree angle, the hypotenuse, this 90-degree angle will face the hypotenuse, which is SP. So SP is congruent to, notice the single tick mark, this single tick mark is also being faced by this 90-degree angle, which is PT. So the hypotenuses are also congruent to each other. And what we can say now is that triangle number 1 is congruent to triangle number 2 by the HL theorem. These are all pieces of information that help you prove using HL theorem that both triangles are congruent to each other. So, how would you respond to this? Yes, comma, triangle SRP is congruent to triangle TRP by the HL theorem. Remember what HL theorem stands for. Hypotenuse leg. And a right triangle is the only one that uses the terminology legs and hypotenuse. So that's another indicator on what to use or when to use HL theorem. You need to have those right triangles in order for this to work. This is your showing your work, and this is your answer at the very end. Yes, triangle SRP is congruent to triangle TRP by the HL theorem. We have one more example, and you know, I always tell you guys, I'm going to try and trick you with this one. Okay? So we're going to look at example number 3, and it asks, are these two triangles congruent? Justify your answer. Okay? So first things first. Do we know anything about that angle? And do we know anything about that angle? There's nothing in the book that indicates anything about those angles. And there's nothing in the diagram that shows us that both of these angles are either congruent or 90 degrees. So basically what happens is it might look like a rectangle, but when I measured this box to create this rectangle or quadrilateral, it's actually a quadrilateral, it's not a rectangle. These are 91 degrees. I measured this to be 91 degrees, and I measured this one to be 91 degrees. So basically, it's not a right triangle. Okay? So this set of triangles here, triangle number 1 and triangle number 2, are not congruent to each other using the HL theorem. Okay? You need to have right triangles in order for that to happen. So, do you have right triangles? The answer is no. So you cannot use HL theorem. But let's see if we can use another theorem. Okay? So we have WZ is congruent to YX. Okay, so that's a side. That's a set of sides right there. Okay, so we also have WY congruent to itself using the identity theorem. And we also know that angle Z is congruent to angle X. Now, does this help us with anything? Well, this is a side, and this is an angle. SSA, or the funny way of doing it is ASS. We do not have a shortcut with SSA. So no, we do not have enough info to say these two triangles are congruent. Interesting, right? Even though we know that this angle, this side, and this side are congruent to each other, we don't have a shortcut for SSA or ASS. These do not exist. So no, these triangles are not congruent to each other. Okay? We cannot use HL, and we cannot use any of the other 4 shortcuts to prove that these two triangles are congruent to each other. We just don't have enough information. So let's go back to the first set of notes. What are now the 5 shortcuts for us to prove that two triangles are congruent? We have side, side, side. We have side, angle, side, angle, side, angle, 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 side, and now the new one for today is HL theorem. Remember, if you're going to use the HL theorem, you need to have 2 right triangles. Their hypotenuses need to be congruent, and at least one pair of their legs needs to also be congruent. That is today's lesson on HL theorem.